A short but precise description of the quality scores in FASTQ files. So here we can see an entry in a FASTQ files. It contains always 4 lines of the text file. The first one is a header line. It's just some code for this read, right? The second one is the sequence itself. This is the read. This is the DNA sequence. 1 line. We only see the first part of it here. Then there is what we call the plus line, which is usually empty, but it could also contain some extra information that was not in the header. And then the 4th line is what we call the quality line. And always, whenever you have a read of a certain length, you have a quality line of exactly the same length. So it means that any symbol up here has a quality symbol down here. So if you look at these 3 symbols here, AAT, what is the quality of these 3 bases? This is what we find in the corresponding positions of the quality line. And these 3 symbols indicate now the quality of these 3 bases. How much can we trust that these bases were actually sequenced correctly, we could say. That's what this quality line is trying to tell us. How much can we trust the sequence, the DNA sequence here, position by position by position. So what we'll actually show now is how these 3 symbols here correspond to some quality scores, which in turn also correspond to probabilities of error. So these are actually the probabilities that we have an error in the first position. This is the probability of an error in this position, and this is the probability of error in this position. And they are all told us by these symbols here. How is this working? We need the ASCII coding table to understand this. There is in this table an integer value behind each keyboard symbol, plus some additional symbols that you don't see on the keyboard. The first visible symbol is exclamation mark, and it has the integer code 33 in this table. This quality score, which is sort of related to this to any symbol in this quality line, you get by replacing each quality symbol by its ASCII value and then subtract 33, which is here. So it means that these 3 symbols here, smaller than, @ sign, and capital F, if you look them up in the ASCII table, you will find that they have these integers in the ASCII table, 60, 64, and 70. Then from each one of them, we subtract 33, right? And you get the quality scores. These are the quality scores behind these 3 symbols. So the symbols are converted into quality scores. From quality score Q to probability of error, it's this very simple formula here. The probability of error is 10 to the power of minus Q divided by 10. So you can see that again we have these 3 symbols. We know that we can turn them into the quality scores, the Qs, these are the Qs, right? And then we can just plug each of the Qs into this formula here and get these probability values. So this is actually the way from the single letter symbol to these numbers here. And notice the reason we have this coding is of course that we want this quality line to have exactly 1 symbol for each base in the read, right? For each DNA symbol, we have a quality symbol. If we use these numbers here, it will be a horrible mess, right? The quality line will contain a lot of numbers and zeros and blah, blah. I mean, we couldn't see where one number starts and the other ends, right? So that's the practical reason for this coding.